open के चलो से जाऊँ भी चाहेंगे जा good morning to all.
Good morning, sir.
Morning, sir.
So let us start. The last class we have discussed 2D transformation. There are some transformation techniques. For example, translation, scaling, rotation, shearing. These are the uh, different transformation techniques. But the scaling and the translation and the rotation is also done using a fixed point. You see, last class we discussed, we have small you see last class we discussed that is when a scaling is performed in any other point with respect to any other point other than origin. So we have to perform three different steps. First, we have to translate that fixed point, which is known as pivot point, to the origin through translation. Then you make the scaling operation and then translate back using inverse rotation. So similarly, the scaling direction also you can done according to your coordinates. That is, you can. This is a general 2D scaling direction. That is, you can also perform scaling operation with respect to other origin, that is other than the origin, other than the x-axis and y-axis, any other axis you see here. Suppose S1 and S2 here, you see two different axes other than x and y. So first we have to rotate here. In initial case, in previous case, we have to first perform the translation, then scaling, and then again inverse translation. Similarly, here also same three steps have to followed. We have to rotate the angle theta to S1 and S2 to x-axis and y-axis you see here. So now perform the scaling operation and then make the inverse rotate direction. That is invert rotate operation. That is where S1 is coincide to x and S2 is going to y, coincide to y-axis. So we have discussed this. This is the matrix property. We know that matrix addition is not commutative. Matrix multiplication associativity. We know this property. But the important thing is matrix multiplication is not commutative. That is A into B may not be equal to B into A. So some you see, if we reverse the order, we will get different output. We have already discussed in the last class. That is, if we first make rotation and then translation, it is different from first make translation then rotation. So if you reverse the order, you may get different output. And the last one we have discussed the reflection. The reflection is about x-axis. You see here, my original position is there. Here is the object. it looks like a triangle. The original position of the triangle is, you see it is marked by dotted line, and 1, 2, 3 are the vertices of this triangle. And after reflection, you will get the output, which is looks like a blue color. You see that is, if we imagine, if we keep a mirror, if you keep a mirror exactly on x-axis, you will get its mirror image of 1, 2, 3. That is represented by, you see, 1 dash, 2 dash, and 3 dash. So you can tell this is a reflection about x-axis. Similarly, we can reflect the another object. Uh, this is the uh, reflection matrix. You see the minus sign is a center, and similarly the same reflection is with respect to y-axis. The original position is here 1, 2, 3, and if you keep the mirror exact on y-axis, you will get an image of the original image or original object. You see the reflect position, which is dependent by 1 dash, 2 dash, and 3 dash, and it is 1, 2, 3, and this is exactly a mirror image. If you keep, that is, you can tell it is a reflection with respect to y-axis, where x equal to 0. And you please mark and please see the matrix, that is the reflection about y-axis, or the line x equal to 0. You know that, or the all the point on all the point x equal to 0 of y-axis. On a y-axis, the x coordinate values are 0. Similarly, on x-axis, y coordinate values are the 0. So it is written that reflection about the line x equal to 0. So x equal to 0 means it is y-axis itself. So you see the reflection matrix. The first entry of the matrix is -1, and the diagonal element are 1, and other are 0. And if you reflect an object with respect to origin, about the origin, you see, if you keep the image on origin, you see this is the reflect object of 1, 2, 3, which is 1 dash, 2 dash, and 3 dash. And you see the reflection matrix. And other to the transformation continue. Reflection about line y equal to x. So far we have discussed reflection about x-axis, reflection about y-axis, and reflection about origin. Now reflection about the line y equal to x, where x and y equal, that is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. These points are the coordinates point are here, where the line in each point are equal. You see this line 0, 0 lies on this line. You see it is passes to origin. The line passes to origin 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So this is your line y equal to x, where all the y coordinate are equal to x coordinate. So this line, you know that divides, that is inclined angle theta in with the origin. You see here, you see the original position 1, 2, 3, and if you keep a mirror on this line y equal to x, which is the line which is represented by dotted line. So this is a line, this line, the equation of this line is y equal to x, because all the coordinate points on this line are equal. X coordinate and y coordinate are equal, and if you keep a mirror on this line, you will get its reflection position. You see, All are positive here, you see, all are the first quadrant. So there is no negative sign in reflection matrix about line equal to y equal to x. Then the reflection about the line about y equal to minus x, y equal to minus x, that is x equal to, if x equal to 0, y equal to 0, if x equal to 1, y is equal to minus 1, and if y is equal to minus 1, x equal to plus 1. So if we plot a line by taking these points 0 0, 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, 5 minus 5, or minus 1 plus 1, minus 2 plus 2, where y equal to minus x, you see the dotted line which represent the line whose equation is y equal to minus x. And if we keep, you see my original object 1 2 3, which is marked or represent in dotted triangle, you see, whose vertices are marked by 1 2 and 3 and written their original position. So the object is now in the original position. So you want to reflect it or find its reflection image by taking or about the line y equal to minus x. That is, if we keep an mirror on this line, the dotted blue line, you see, and you will get exactly the same mirror image, which is represented by blue color triangle, 1 dash, 2 dash, and 3 dash. So this is reflection about a line y equal to minus x. So, so far we have discussed the reflection about x-axis, reflection about y-axis, reflection about origin, reflection about the other lines besides x-axis and y-axis, that is y equal to x in previous slide and y is equal to plus x in this slide. Then the new transformation is shearing or shear. It is the last 2-day transformation. We have discussed 3 plus 2, 5 transformation, translation, rotation, scaling, reflection, and shearing. As you know, translation is used to change the position or location of an object. Rotating means you can orient or rotate a body or an object with specified angle. Scaling means if you want to change the size of the object either to enhance or increase or decrease. Reflection means it is reflection image, is a mirror image, you may tell that is it a mirror image. And shearing is used to change the shape of an object. You see, uh, transformation that distort the shape of an object so that the transformed shape appears as the object was composed of internal layers that had been caused to slide over each other. Uh, you see the picture. The first one is the your uh, a blue color. There is, it looks like square. So after sharing, that is, you will get the same area object, but the shape is changed. The shape is changed. Uh, it's look like a parallelogram. So here uh, two sharing factor is used. One is SSX and SSY. Let us see discuss about that. What is sharing? Like a translation factor is there. TXTY we have used. So here two translation factor is used. So you see here. Here SS is two. Let us discuss about what is SSX. You see, an X direction share relative to X axis, which is known as SHX. Similarly, an Y direction shear relative to the Y axis, which is known as SSY. So an X direction shearing relative to the X axis, the matrix is 1 SSX 0, 0 1 0 and 0 0 1. That is, the X dash value will be changed and there will be no change in Y value. That is, Y value is same as Y. You see the previous class. You will get its difference by comparing its Y coordinate. You see in the both picture, the Y coordinate are same. There are 4 pointers given 0 0. You see the original position, the original object. You check the Y coordinate of the first object. The Y coordinate of first object. The first point is origin 0 0. The second point is, if you go then 1 0 1 1 0 1. You see here first point is 0 0 1 0 1 1 0 1. In second image you see all the Y coordinate value remains same 0 0 1 1. The Y coordinate of the original figure is 0 0 1 1. The origin is 0. The next point is also 0. The other points are 1 1. So all the Y coordinate are same. In both the figure, only there is change in X coordinate, because we have taken X coordinate is SX2. So if we apply the shearing matrix on these values, you will get X dash is equal to X plus SX into Y. That is, we have to change the relative value with respect to Y. So if SS is equal to 2 here, you see, so S dash will
So
0
the
plus
height
2.
remains the same, sir?
No, height increases. Height may changes. Height may not be equal. You see here, the wide coordinate remains same. The X coordinate is S dash equal to X plus SS into Y. That is 0 0 equal to, you see here, S dash equal to X plus SS into Y. That means X is equal to 0. Suppose you take the origin value. So not origin, because origin is same. You take the value 1 1. There is a point 1 1, isn't it? In the original position.
Mm.
Yes, there is point 1 1. You consider that point. Y cannot remain same. That is, the 1 1 point, it changes to 3 1. It changes to 3 1. That is, Y coordinate value remains same.
So 3 is Y,
No, no, 1.
1 is Y. Okay.
1 is y. Well, first, the 3 is first point, no? First point of the y coordinate. Hota. Okay, you see the x coordinate. S coordinate equal to the new value of 1 is now changes to 3. How? That is x dash equal to x plus 1 plus 2 into y. That is 2 into 1. 1 plus 2, 3.
Mm.
Okay. So similarly, the other x
In the
values are
first
changes.
in the first one, it is becoming 2 because
Yes,
0 is
obviously, yes, yes, yes. 0 plus 1 into 2. X dash equal to x plus sh into y. That is 0, new value equal to 0 plus the y value is sh equal to 2 and y is equal to 1. 2 into 1, 2. So 0 plus 2 is equal to 2. So that point is shifted to C 2, 1. So if you join this 4 point after calculating the value of SHX and the new value of X dash, you see the shape changes. The shape changes. That the first the shape are different from the second. So sharing is used for these purposes. Similarly, and y direction sharing related to the y axis. Here the equation are different. You see. Here the equation not given, I think. The equation should be, I have not written, I think, that is x dash equal to x. X dash will not change, s will not change, and y dash equal to y plus shy plus x, shy into x. In second matrix, I think the equation is not given. You may write in your copy, that is x dash equal to x value will not change. But y dash equal to that is y plus shy into x. There will be a interchange of x and y for the y direction sharing relatives. S dash equal to x, y dash equal to y plus shy dot x. So this is your x direction sharing and y direction sharing. So x direction sharing relative to other reference line. That is, you want to perform the sharing operation with respect to other line, but in x direction. Okay, in x direction, it is shifted. That is x direction, but the line is not with respect to the x axis and y axis. So that is same as here, but we have to take 1 SHX minus SHX into y reference. 0 1 0 0 1 0, and the equation C, the equation is important. X dash equal to SHS into, in previous one we have only multiplied y, but here y minus y reference, and the value of y remain unchanged. That is y dash equal to y, because we are performing here x direction sharing. So you know that in x direction sharing, the value of y remain unchanged. Similarly, in y direction sharing, the value of x remain unchanged. So if we take an example, it is a better example of y rep, where y referential minus 1. this is a x direction sharing, but with respect to your another point, that is y equal to -1. But it is a x direction sharing. Here taken SS is equal to half 0.5 and y difference is -1. If you put this formula, you will get this one. That is s dash equal to s plus ssx into y minus y dash, and y dash remains same. That is, it is as it is x direction sharing, y will remain same. You see, all the y coordinate value remains same. 0, 0, 1, 1. Here also 0, 0, 1, 1. So you will calculate the values of y from the original position. You will get these values, half value of x. So you see 0 is shifted to half because it is reference to y. It is not reference to the origin. In previous case, you see, after sharing, you see, after sharing, the initial point is at origin, which was initially there. The 0, 0 is in original position, and the 0, 0 is also in second one, the output also. The other point changes. The other point changes. That is, if we draw a line, it passes about the first 2 points, left side 2 points, it passes to origin. That is the corner is in the origin. But you see here, if you draw a line, that is it passes through y minus 1. Y reference, you see, the point y reference equal to -1. That is, I mean to say that you put a scale on first 2 point of the parallelogram, that is in figure B, and if you draw a line, that line passes through the point -1, y reference -1. So this is a x direction sharing with respect to another point, one y, that is known as y reference. Similarly, y direction share related to the line x equal to x reference. Y direction sharing relative to the line x equal to x reference. 1, 0, 0, you see, this is your the same formula. Here the x value will not change. Because it is a y direction sharing. And y dash equal to x plus shy into x minus x reference. Logical. In a sharing, we have x dash equal to x and y dash equal to x plus shy into x only. Here we have multiplied x minus x reference in place of simple x. And this is an example to illustrate that. Unit square A. Unit square means that is your all the height of this, or the length of the side of this square is 1. So it is written as A unit square. That is why uh, is torn into a separate parallelogram with value SHY is equal to 0.5 and X reference equal to -1, and it is a y direction shearing transformation. That is, you have to shift it on y axis. Unit square A is turned into shifted parallelogram. You see the shape changes. Initially it was a square, now it changes to parallelogram. And here y direction shearing uh, with a x referential -1. That is, you may check if we draw a line zero half and 1 1, keep your scale in 1 1 and 0 1 by 2 points, below 2 points. Keep your scale and draw the line. So it will passes to x reference -1. So it is a shearing, y direction shearing, uh, and that was in x direction shearing. But it is related to another reference point, x equal to x reference or y equal to y reference. So, transformation नहीं बस. So it was your 2D transformation. And this is the last slide of 2D transformation. So have you any doubts or any issues regarding 2D transformation? No.
सर एक 2D ट्रांसफॉर्मेशन में किस टाइप से क्वेश्चंस पूछ सकता है एग्जाम में? I mean, it is looking some lengthy kind of thing. तो
No,
न्यूमेरिकल्स आएंगे कि कैसे आता
हाँ,
इसका?
न्यूमेरिकल आ सकता है. Okay, you will
अच्छा,
get numerical questions. That is, this is the values, and you can also get only theoretical question. What are the
ओके,
what are the sharing? What are the different type of sharing? Or you may get a numerical value and find its sharing value after x sharing, x direction sharing with reference equal to x equal to x -2. Okay, so you may get your numerical question, but the question are not lengthy. Okay, the lengthy question are not there in 2D transformation. It is either in numerical form or in a theoretical form.
So geometrical type of the question may be coming, right?
Hmm.
कोऑर्डिनेट्स वगैरह का जो क्वेश्चन होता है, दैट
हाँ
काइंड ऑफ
coordinates
क्वेश्चन.
वगैरह, हाँ yes yes.
So far no doubt, sir.
Okay. Then next, we go to next and new topic, computer vision. It is not. Is it visible? Computer vision? No, no. 1 minute. Is it visible? A new slide is visible or not?
नहीं सर,
No
अभी
sir,
पूरा
no.
active है.
Last one we can see only.
Okay, no.
ट्रांसफॉर्मेशन वाली दिख रही
Apple.
है.
अच्छा हाँ. That file जो over already. 1 minute.
Sir, is there any practical kind of thing in this subject?
The practical question actually are different.
अच्छा.
I have to close that file.
Yes sir, 2D geometric transformation. Nothing
Please
is
wait
showing
one.
now.
Is it visible now?
Yes sir, computer vision.
Computer vision. So, what does it mean, computer vision?
सेल्फ ड्राइविंग कार वगैरह की चलाने में काम आता है सर.
That is actually, whenever you see an image, we get some information in it, from it, isn't it? Suppose you see an image of a tiger. So you get some information from it. That is, this is a tiger head, this is tiger ears, this is tiger nails are big, and this is tiger's tail. So you get some information, and the color of the tiger is yellow, and it is a black scripted. So you will get some information from tiger. Also, you will get some information which is relative to you, which is important to you, and to which you are, suppose you are searching or research. Suppose your research point of view, you can get some information. Suppose you are researching in an image which is come from your satellite, and you will see that is a particular object is there or not. A particular object is not yet there. So this is a human point of view. As the name says, computer vision, this is the view of computer. How computer sees the image, how computer checks the image, how the computer views an image. We are humans, so we have eyes, we have brains. So whenever we see an image, we know that this is an image of a tiger, this is an image of an elephant, this is an image of a tree. So we get that information. But how does the computer knows that is it is a vehicles and it is a human? For a best example is your face recognition system. Sometimes you see that is a computer or this vision, that is you know that where is a face of a human is. Have you ever seen in your camera?
Yes, sir. The face detection system in the photographs taken by the phone, it detects
Obviously,
the
obviously,
face.
yes, yes, yes.
We can even filter the all the photos according to the faces.
Hmm, hmm. Okay, so sometimes suppose you want to view the vehicles in the road. The other object you are not interested. You are interested only to see the vehicles on the road. Suppose there is a crowded road and you want to see the number of vehicles. So the computer will let you know that is which are the vehicles. It may draw a square on vehicles. It may mark something in different color that these are the vehicles. No, so this is human vision. Sorry, computer vision. The same definition is written here. Computer vision is a branch of artificial intelligence that enables computers to interpret and extract information from image and video, exactly similar to human perception.
Sir, in videos, how it will help? I mean, as you said that in in
You see,
crowded area, if you
you
wanted
see,
to see only vehicle, then it will
hmm,
find out or track, I mean, fetch out only vehicle from the crowd. If the
Achha, suppose you
human
see,
and the vehicle both are in the crowd, then it will find out or show us only the vehicle.
hmm.
But what about the videos? I mean,
Suppose you
how it
see,
will?
suppose there is some mishappen happen. Suppose like some has stolen from a store. Okay.
Okay.
So there is a video in your capture in which camera? CC camera. Okay. Suppose then police came and took the video and they checked. Okay. And they checked. And say they are only interested the person. You know that in that road, suppose the store is in a crowded place, a busy place. There are a lot of peoples are suppose going on at that time. Suppose they only are interested to see the person, those are spurious, not all the persons. Okay, you know that the thieves are not moving, are not exactly same as the if normal person. So there are his or her movement are different, isn't it? The thieves are moving, a normal person is moving. So the dress code and the movement are different. A thief may have a monkey cap, may have a full sleeve shirt or pant. So they want to hide their faces. So they become spurious. So from that video, the artificial intelligence let you know that these figures are spurious. Okay, these figures are spurious. They may be the thieves. Are you getting?
Yes, sir. Got it.
Hmm. So from the video, they will also the computer also view that. That is, it will see if there is either a human or other person, normal person or a thief.
Sir, so I mean to see this kind of the videos. Computer requires some special kind of software to be installed.
Obviously, that is the feature of artificial intelligence. That is the feature of one the feature of artificial intelligence. Okay, it already know that it may be spurious or not. So it is a feature of main artificial intelligence. So computer vision also a branch of that artificial intelligence. It involves developing algorithm. You see, your answer is the second. It involves developing algorithm to or process visual data and derive meaningful insights. So there are some algorithms. There are some you can tell there are some methods. There are some softwares which is used to recognize those things. 1 minute. Why? Why computer vision? High demand in the job market, essential for careers in AI, machine learning, and data science across industries like healthcare, automotive, and robotics. So these are the major industry, healthcare, automotive, and robotic nowadays, and essential for career in AI, machine learning, and data science. And these are the powerful tools which are now going on the market. Artificial intelligence. 1 minute. Reporting revolution. Revolutionizing industries, powerful advancements in self-driving cars, medical diagnostics, agriculture, and manufacturing by automatic visual text, solving real-world problems, enhances public safety, improves medical imaging, and optimizes industrial process. So these are the different type of application where the computer vision is used in this. These are the purpose we learn computer vision. What is this application? Like 1 minute, 1 minute, 1 or 2 minutes. You see, uh, we may see a machine can see and understand the worlds around them, much like human do. So that is why the name is computer vision. So this is the magic of computer vision, a branch of artificial intelligence that enables computer to interpret and analyze digital image, videos, and other visual inputs. So analyzing that, it automatically gets some information so that we can use in our research way or in our desired way. From self-driving cars to healthcare diagnostics, computer vision is revolutionizing industry by allowing machine to recognize object, track movement, and even make decision based on what they see. So this is like a human, the computer vision view the images, videos, and on the other visual inputs, and it is recognize which type of object this is, and it takes the proper decision, or it let the human know what are those factors. And it is major application are oil and natural gas. Let us see how the application is oil and natural gases. The oil and natural gas company produce millions of barrels of oil and billions of cubic feet of gas every day. But for this to happen, first the geologists have to find a feasible location from where oil and gas can be extracted. So the geologists have to find a feasible location from where oil and gas can be extracted. It is not no, easy for the geologists to move all the parts of the world and to recognize which part is belongs to the oil and gases. So to find this location, they have to analyze thousands of different locations using image taken to the spot. If you done this work manually, you imagine how it takes a lot of time. So to find this location where the natural gas or oil are there, you have to analyze thousands of different locations using image taken on the spot. Suppose if geologists had to analyze each image manually, how long would it take to find the best location? Okay, this is the question. That is, if you image it manually, they take more time, maybe months or even a year, but due to introduction of computer vision, the period of analyzing can be brought down to a few days or even a few hours. Okay, so if you done by the machine or our computer vision, this job can be performed in fast or in a few days or even a few hours only. And if the geologist or human, uh, if the geologist, they have to take a long time. So this is the first application. Hiring process. In the HR world, computer vision, in HR world, computer vision is changing how candidates get hired in the interview process. By using computer vision, machine learning, and data science, they are able to quantify soft skills and conduct early candidates assessment to help large companies shortlist the candidate. So for HR, in a huge company or big company, they also take the help of computer vision. So what did they do? So by using the computer vision, machine learning, and data science, they are able to quantify soft skill and conduct early candidate assessment to help large companies shortlist the candidate. And then the video surveillance. The concept of video tagging is used to tag videos with keyword based on the object that appears in each scene. Suppose the keyword is animals, so it can that is you are tagging the animals. So animals only are tagged. Now imagine being that security company who is asking to look for a subset of a blue van amongst hours and hours of footage. It has to feed the video to algorithms. With computer vision and object recognition, searching through video has been a thing of the past. That is, suppose there a lot of vehicles are there, but they are searching vehicles with blue color, So only blue color vision, blue color vehicles will be visioned by computer. So if you the security companies who's asking to look for a suspect in a blue van ammo. So there is a suspect in a blue van. Okay, there are a lot of vans there or vehicles are there, but we suspect a blue van are there. So we can only want to interested to view the blue van only or blue vehicles only. Okay, it has to blue van or vehicles. It has to feed the video to the algorithm. So with computer, the algorithm is already there, the software is already there, the video is only feed. That is, the video is given in an input, and with computer vision and object recognition, searching through videos has become a thing of best. Construction company. Suppose this computer vision in AI also it has an application in construction line. For example, the electric towers or building which require some degree of maintenance. Suppose there is a electric tower or building. Suppose it may be a tower there. Just suppose it made of iron. Some degree of maintenance to check for the degree of rust or other structural defect. So if you climbing it manually of the tower to look at every inch and corner would be extremely time consuming. It takes more time. Not only the time consuming, it is also but also costly and dangerous. So imagine if the person on the ground took high resolution image from different angles. Then the computer vision specialist could create a custom classifier and use it to detect the flaws or amount of rust or crack present. That is, a person uh, can take the high resolution image on the ground from different angles, and these images are handed over to a computer vision specialist. So he may find a classifier or use it the detect, use this image, view the image, and also find the amount of rust or cracks present in it, and so that the maintenance work will be done properly. Besides construction, there's a healthcare. From the past few years, the healthcare industry has adopted many next generation technologies that include artificial intelligence and machine learning concept. On the one of them is computer vision, which helps determine or diagnose disease in human or any living creatures. So the computer vision is also used in healthcare industry. So from and machine learning concept, one of them is computer vision, which helps determine the diagnose disease in human by viewing the or getting the information from the image. Also, it is the application in agriculture sector. The agricultural farms have started using computer vision technology in various forms such as smart tractors, smart farming equipment, and drone to help monitor and maintain the field effectively and easily. It also helps improve yield and the quality of crops. So this is also used in agriculture sector. Smart tractor are there, smart farming equipment are there. You may view all the farming equipment are used nowadays, and drones to help monitor, and also drones are there, which is a some drones which are flying. It has the high resolution cameras to capture the image and maintain the fields effectively and easily. It also helps improve yield and the quality of crops. Besides agriculture, it is military. For modern armies, computer vision is an important technology that helps them to detect enemy troops, and it also enhances the targeting capabilities of guided missile systems. It uses image sensor to deliver battlefield intelligence using for tactical decision making, also used in military. We get some information, suppose that is there are some other country or neighbor country is constructing some uh, in constructing some, suppose aeropad or something near the border. It obviously from the satellite, the high resolution camera are there, it captures the image and the information we easily get, that is there are some spurious movement of our enemies. So it detect the enemy's movement near our border, and it enhance the targeting capability of guided missile system also. So the missile system also guided by this computer vision or AI. It uses image sensor to deliver battlefield intelligence used for tactical decision making. Industry. In manufacturing or assembly line, computer vision is being used for automated inspections, identifying defective products on the production line, and for remote inspection of machinery. The technology used to increase the efficiency of computer vision technologies, which is a dream come true for humans. Self-driving AI analyze data from a camera mounted on the vehicles to automate lane finding, detect obstacles, and recognize the traffic signs and signal. So you see the application of computer vision in AI in almost all the sectors. Automated lip reading also, This is one of the practical implementation of computer vision to help people with disability or who cannot speak. It reads the movement of leaves and compare it to the already known movement that are recorded and used to create the model. So this is also the computer vision also read the leaf reading of a person. So image fundamental of image formation. Image formation is an analog to digital conversion of an image with the help of 2D sampling and quantization technique that done by the capturing device like camera. So we already know that the conversion of analog to digital conversion is already done in two processes. One is sampling, another is quantization. Basically, sampling is used to find the location of an object, and quantization used to gray level values of a pixel. That is done by the capturing device like cameras. In general, we see a 2D view of the 3D world. We know that our general skin is a 2D screen, a two-dimensional, but the object is a 3D. So that is written, we see a 2D view of the 3D world. In the same way, the formation of analog image took place. It is basically a conversion of the 3D world that is our analog image to a 2D world that is our digital image. So as you know, the digital image is 2D, two-dimensional. It contains two part only. One is your sample, one is your location, and another is gray level value of that pixel. That so, but our analog image is a 3D object. Suppose you capture a picture of a animal. You know that the animal is a 3D 3D object, but it is captured in a screen, which is a 2D screen, two-dimensional screen. Basically, our screen is a 2D dimensional screen. So a frame grabber or a digitalizer is used to sampling and quantizing the analog signal. The mapping of a 3D world object into a 2D digital image plane is called imaging. So imaging means that is there's a mapping should be done to the 3D world to the 2D image. That is, there must be a mapping, because when you capture a picture, the size of the object is very large as compared to your screen size. Suppose you take the image of a tree, suppose a coconut tree. So in your screen, so a tree is the size of the tree is much bigger than the screen, but it is captured within the screen. So there must be a mapping. There must be a mapping for that object to your 2D screen. So the mapping of a 3D world object into a 2D digital image plane is called imaging. In order to do so, each point on the 3D object must correspond to the image plane. So there should be an imaging or mapping from the 3D object, analog object, to the 2D digital image.
Sir, how do we get 3D images?
3D image, actually, it is the latest feature of camera use, lenses we are using nowadays. Okay, but actually, you compare our image, that is a 2D plane, isn't it? It is a 2D plane. They are two dimensional. We cannot see the 3D object. But nowadays, we get a 3D object, 3D mirror. Sorry, 3D image. Okay, so that principle are different. The camera, there are latest camera are there, something are there. So it is we are able to view nowadays we are view, but basically the our screen is 2D, so we have to capture a 3D object. So this is a mapping from the 3D object to the 2D screen. For these purposes, the lens and mirrors are crucial in focusing the light coming from the 3D scene to produce the image on the image plane. How do we see? We have lenses. We have eye lenses. Suppose you see an image, suppose the human eyes. You take the example of human eyes. So human eyes, suppose you see an object, it is nearer to you. It is adjusted. Isn't it? It is adjusted, that is the scene is falls in the focal point, you can focal point of the eye, so you can view the image. If the same image is very large, sorry, in very away from you, suppose you can also view it. No doubt the size will be different, but you can view it. That is, it's also image point and also like your focal length. So that is the lens in your eye is adjusted in so manner that you can view the object which is nearer to you, also very farthest to you. So this is a you can tell it is a God gift. It is a God gift to us. The lens are automatically adjusted. Okay, so you see, similarly the lens and mirrors are crucial in focusing the light coming from the 3D scene to produce the image on the image plane. So this system define how light is collected and where it is directed, and consequently affect the sharpness and quality of the image produced. Image sensor. The goal of image sensor like the CCD to the CMOS sensor, there are two types of sensor. CMOS sensor are to simply transform the optical image into an electronic signal. The sensor differ by sensitivity, the resolution that they deliver affecting the image as a whole. So this plays a role for capturing an image. The resolution and sampling. The resolution is defined as the sharpness of an image, and it occurs technically as the number of pixels in an image can hold. So you know that if the image contain a large number of pixels, so the quality is better. If an image contain less number of pixels, so the quality is less, and it depends upon the, we call it image size. Image size. That is, if image size is large, a pixel may contain less number of pixels. If the image size is less, so an image contain a large number of pixels. So it depends upon the pixel size. Sampling is the act of taking samples or discretizing a digital signal and representing a continuous analog signal as a group of discrete values. It can be seen that higher resolution and approximate sampling rates are required in order to provide detailed and accurate image. So sampling rates is also important, and the resolution is also important. You have to see the higher resolution. So resolution should be perfect to view an image. Image processing can be described as the act of modifying and enhancing digital image by using algorithm. We already know that. That is, if we image are using a computers, computer means there are some algorithm. There are no humans. You have no manual option to doing anything. So the processing on image by computer means the process of computer by an algorithm or software. So image processing can be described the act of modifying and enhancing digital image by using algorithms. Pre-processing includes activities like filtering, noise reduction, and color correction that enhance image quality and information extracting. So we have already discussed how the filtering is done. There are different filtering physical. There are different filtering we discussed in the last class. Mean filter, media filter, smoothing filter. There are different filter used. Noise reduction and color correction that enhance image quality and information extraction. So that is when we need image processing. We have already discussed in the earlier. Then color and pixelation. In digital imaging, a frame grabber is placed at the image plane, which is like a sensor. So a frame grabber is there. It is nothing but like a sensor. It aims to focus the light on it, and the continuous image is pixelated via the reflected light by the 3D object. The light that is focused on the sensor generates an electrical signal. So the focus of the light on it, and the continuous image is pixelated via the reflected light by the 3D object. So by the reflected light, it is pixelated. The light that is focused on the sensor generates an electrical signal. And each pixel that is formed may be colored or gray depending upon the intensity of the sampling and quantization of the light that is reflected and the electronic signal that is generated via them. So each pixel is formed that may be color or gray depending upon the intensity value, gray level value of the sampling and quantization of the light that is reflected and electronic signal that is generated via them. All these pixels form a digital image. This type of picture, all these pixels form a digital image. The density of these pixels determine the image quality. This is important. The density of the pixel, as we discussed, if the number of pixels is more, that is, if the size is less, the number of size is pixel less. If the density is more, and determine the image quality. So more is the density, more is the better quality, more quality. The more is the density, the more is the clear and high resolution image we will get. So if the density is more, that is the number of pixels in a unit area is more, the resolution is more. So the density is more, then the clear and high resolution image we will get.
ये फ्रेम ग्रैबर कुछ एग्जाम्पल दे सकते हैं सर?
हाँ, frame grabber is actually there when you take a picture from a camera, there is a sensor which is known as frame grabber. It grabs the picture, it captures the picture from a 3D scene. There is 3D scene. Suppose you are capturing some image, and there is a sensor look like that, and it senses that, and it looks like that is some rays coming in form of signal. Like your eye, how you see an object. Suppose when you see that is some lights are coming from it, and it is falls our focal length of our eye. That is how you can view it. Similarly, when you take the capture, so there is a frame grabber. It is like a sensor. It senses that is the object and take the object, and some signal coming from some light coming from that image in form of signals. Okay, so here also the same process is do for converting, sampling and quantization. So you know that sampling is a spatial resolution on the digital image, and the rate of the sampling determines the quality of the digital image. The magnitude of the sample image is determined as the value in image processing, and it is related to the coordinate values of the image. So as you know, the sampling is always determine the location, the coordinate values of the image. Okay, so after the sampling, then the quantization is required to determine the gray level value. So once we get the location and the gray level value, so that pixel is already formed, and a digital image is consist of such type of many pixels. So quantization, the quantization is the number of gray level in the digital image The transition of the continuous values from the image function to its digital equivalent is called quantization. And most important is it is related to the intensity or gray level value of the image. The same thing is there, sampling and quantization. The normal human beings acquires a high level of quantization level to get the fine shading detail on the image. The more quantization levels will result the more clear image. So if the quantization level is more, that is so you will get a clearer, better quality image. So what is the advantages? So when you take an image, it is formed digital image, and digital image is less susceptible to humans factors and gives accurate output of the object with high detail capture. As you know, there are some advantages of digital image. It takes less space. It is a 2D object where that is a 3D object. So it is if you convert it to digital image, it is better for the image processing. Enhanced flexibility. Now, let us see what are the flexibilities there here. Digital images are easy to manipulate, editing, or analyze as per the requirement through different software. Hence, they provide flexibility of post-processing. So, if a computer, sorry, if an image is manufactured by a computer means there are some specific algorithms, some specific software used for that purpose. So, a digital image is easily edited or manipulated by a software. It is not done by the uh, people manually. So it is easily manipulated or edited by the software and analyzed as per the requirement. So there are different softwares, hence they provide flexibility and post processing. Nowadays you may find different type of apps used for these purposes. You can download that application. You can edit an image easily. You can change the shape. You can change the color. You can add something, some component, and you can also remove some component from the image. So this is enhanced flexibility. That is, digital image can be edited or manipulated easily. High storage capacity. Data in any digital format, such as in one or more digital image, can be stored in a large amount with very high resolution and quality and will not suffer physical wear and tear. So if it is stored digitally in a system, so there are no physical wear and tear. That is, if you store your image in physical, suppose you take a printout and keep in your dryer. So after some days, you may find the color will be changed, and it may, if some water drops on it. So it is also there are some the quality, there are some decrease in quality. So it is free from any physical wear and tear. Easy sharing and distribution. This is important. That is, you can easily share. And you can easily send to your friend and if image is captured digitally. The use of digital image allow them to be quickly duplicated and transmitted across various channels and to various gadgets, helping to speed up the work. Advanced analysis capabilities. Digital imaging enables the application of analytical tools, including image recognition and machine learning, which can provide better insights and increase productivity. So digital imaging enables the application of analytical tools, including image recognition and machine learning, which can provide better insights and increase productivity. Although these are the advantages, it may suffer some disadvantages. Data size. Large structured digital image could occupy large storage space, and computational power hence may be expensive. So sometimes large structural digital image, large resolution image may occupy more space. So uh, computational power hence may be expensive. Image noise. Digital image may be compromised by noise and artifacts, which degrade the image quality mainly when photographed at night or using low image sensor. If the uh, uh, that is the if the camera is not powerful or not a better, so you may get image noise. Basically, if the lights are low, if the lights are low or at night, you there are some noise, there are some images which does not give you perfect quality. Dependency on technology. Digital imaging entails the use of sophisticated technology and equipment that may be costly, and there may be constant need to service or replace the equipment. So as there are electronic equipment, then need to replace. You cannot use your phone for all the time. You cannot use a camera for all the time. So you have to replace it, and the equipment may be costly. Okay, so this is a disadvantages or demerit of capturing a digital image. Privacy concern. The ability to take and circulate the photograph digitally also poses concern because personal information can be photographed without the subject permission. Okay, so this is also a problem. There are lack of privacy. That is, your personal photograph may be circulated, may be shared in nowadays in different uh, platform. Besides that, there is a data loss risk. Digital image repositories, however, are prone to data loss caused by hardware failure, corrupting software, or unintentional erasure. That is, if the hardware is failure, suppose your hard disk is crashed, you may not get your data back. No doubt there are some uh, recovery technique are used nowadays. You can recover the data, but this is also a chance that you may not get your data back. Corrupting software, the software, that may be corrupted on time, may not work as expected. So due to there is some corruption of software or unintentional erasure. Suppose somebody delete the message or an image permanently from the computer, so there will no way to get the data back. Suppose they mistakenly or unintentionally erase an object or delete an object or image. These are the applications. You know that is in medical imaging. Digital imaging is employed in the medical fields, the diagnostic process such as X-ray. Okay. So from the X-ray report, a doctor can recognize about the disease. MRI scan also there. CT scan also there. These are the uh, images and medical images. From these reports or from these image, the doctors, it helps the doctors to diagnose the disease in a patient body, because MRI scan detect internal body reflections. That is the data, the report will come from internal parts of our body. Surveillance and security. You know that digital camera and imaging system are greatly needed for various security or surveillance purposes, as they offer live feed and also and are also useful in acquiring data for investigations. Digital imaging plays an important role in remote sensing application in terms of monitoring and mapping of environment and disasters and involve data capture from satellite and aerial systems. So it is also in remote sensing, and this example is capturing image from uh, satellite. Entertainment and media also. The entertainment industry involves the use of digital imaging in films, video games, and virtual reality to deliver improved visual impact. Scientific research. Digital imaging helps in scientific studies through providing best picture at research fields like astronomy, biology, and material science. So this is another sector where the application of digital image is used. Digital imaging is used in scientific studies through the provide best picture of research field like astronomy or biology or material science. Please see there is a image, and you see this image recognition using the most powerful object detector. One type of object detector. YOLO V7. This is an important detector. You see, it detects almost all the object present in this image. You see, there's a person, uh, chair. Where is a chair? Also, it is recognize that. There's a cup. You see, it's also by recognize. There's a book on the table. It's also recognized by the detector. And some person, the person is also detected by the object detector. You will find different object in this picture, and you see how it is detected by a machine. So here the computer vision in AI is used to detect the object. There are some specific algorithm used for that purposes, specific software that used for that purposes. It is recognized that the object is looks like a cup, it is looks like an person, it looks like a chair, it looks like a dining table, it looks like a laptop. So we'll discuss that introduction to object detection using image processing. So we'll discuss that in next class. Introduction to object detection using image processing. Okay, so you write your name and registration number. Those who have not written, please do not repeat. It will be a problem for me. Please wait. I will take an photo. How many are joined?
Sir, can you please share this PPT in the group? Last week, I think it was not shared.
Which PPT? Today.
Yeah, today's. Both the PPTs, sir. Even the last one was not shared.
I have not shared. Today
No.
transformation I have not shared. No, have I
No.
shared?
Yeah.
Okay. 1 minute. Wait. I have just shared. Otherwise, I will forget.
That's why he reminded you, sir. Busy person.
Today transformation.
Yes, sir. 2D transformation came. Can you please share this one also, the one that you are?
This one actually not in my system. No, sorry, not in my mobile. So I have
Okay,
to
later
take
you
from
can
the.
share.
Okay, I will.
Thank you.
Please wait. I have to take the one snapshot. Then you will leave. Please wait 1 minute only.
Sir.
Okay, thank you. I have taken the attendance and also the snapshots. So now you can leave now. Thank you to all for joining.
Thank you, sir.
Thank you.
Thanks a lot, sir. See you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.